vehicle. And then you need to consider the force along the roadside and then perpendicular to the roadside. So this is mv squared over r. And then we will decompose it along the road and then perpendicular to the road. And then in order to provide enough reactions, usually we will have the super elevation to counteract these forces. Because actually when you're turning around, there will be the force pulling your vehicle. Actually, we need to provide enough force in order to balance this centrifugal force. So for here, you can see that mg is actually the cell weight of the vehicle. And the mv squared of r is actually the centrifugal force which is pulling on your vehicle. In order to balance this force, actually, it depends on the so-called cell weight when we consider there is no friction. Saying that this one, the gradient is equal to x. Then if you have the so-called the component, consider this one is actually also x. And then the force in the along the road is actually mg sine x. Because when the vertical force is actually equal to mg, the component in parallel the road is actually equal to mg times sine x. And then for the other side, actually it is equal to mv squared over r. And you can see that this one is also equal to x. And then the centrifugal force is equal to mv squared over r and then cosine x. So if you consider the equilibrium along the road, actually you have mv squared r cosine x, which is actually from the centrifugal force. And the mg sine x is actually the force due to the gravitational force. If they are just equal, that means this f is equal to 0, then they are just balanced with each other, these two forces. Then you can see that v is equal to square root RT tangent x. So that means under this speed, actually they can self-balance. There's no friction between the tire and the road. That means if you have these so-called elevation, super elevation, then actually if you travel with a V-bar, that means the self-steering speed, then your vehicle can turn around the curve without difficulty. Because the force, they just balance from each other. However, if you have a larger speed, larger than V bar, that means the self-steering speed, then the F will be larger than 0. Because actually the centrifugal force will be larger than the cell weight component. Then, at that condition, actually, it will be held by so-called friction. The friction between the tire and then the pavement. Okay, it is mu n. Mu is actually the friction coefficient between the tire and the pavement, while n is the normal reaction of the vehicle. And then actually we can express that for A is the inner edge of the road, while B we call it the outer edge of the road. Here we call it the inclination of the road surface to horizontal alpha, where alpha is actually this one. It's actually the x. And super elevation of the road is E, we call it the E. is actually equal to the tangent alpha. So tangent alpha is actually the elevation. This one, let's say, actually it is the alpha is the same. So right here, as I mentioned, mv square cosine alpha actually can be depends on two components. One is mg sine alpha. This is from the cell weight, and the mu n is actually from the friction. It actually works against the so-called centrifugal force. We try to pull the vehicle from the lane. And then this one is actually the force parallel to the road surface. And then for the one perpendicular to the road surface, actually you have this mg cosine alpha. And then you also have this one mv square alpha sine alpha. This one is perpendicular to the road. So you have this one, which is actually perpendicular to the road. This one is actually the component of this. And then this one is actually the component of this. This mu n is actually deflections. You just consider the component of force of mg along the road and then perpendicular to the road. Then you can derive these equations. You have 1 and then 2. One is parallel to the road surface, and the other one is perpendicular to the road surface. And then just substitute 2 into the 1. Actually, right here, you have n here. Just substitute n to this equation. Then just substitute the whole n here. And then you divide the whole equation by mg. So you divide by mg here, mg here, and then mg here. And then you get the expression for this. And then further, you put the left-hand side and the right-hand side, you put the terms. So you have sine alpha, cosine alpha on one side, and then the other side is actually v squared over gr minus mu, and then you have mu v squared over gr plus 1. And then because actually the friction, the nu is relatively small, so this one nu is relatively small. So when 1 plus something is small, because you have something small and then you divide it by something quite large. So this one can be equal to 1. So tangent alpha actually equals to v squared over gr minus mu. So that's why you have this one. Because mu is a little bit small. While tangent alpha is the super elevation, so E is equal to v squared over gr minus mu. And then from here you can derive the radius of curvature. That means the radius that you can turning around on the horizontal curve. Now you can see that for if you want to increase the R, I mean you can. If you want to reduce the R, that means the radius of curvature, you want to reduce it. actually you can increase the U. That means you provide high frictions. And then you can provide larger elevation, super elevation. Then you can reduce the R. Now why I want to reduce the R, you can think that from here to here, I need to from this way to this way. I need to turn around. Then if I have not enough elevation, I need a very large radius of curvature. If possible, I can turn around in this way. Then the radius of curvature is much smaller. Right? My purpose is, for example, I just want my vehicle to turn around. One with actually much larger R, this R is much smaller, right? If you want the vehicle to turn back with a smaller radius of curvature, and with the same speed, then actually you may increase the frictions, coefficients, or you may increase the super elevations. Then in this case, you can reduce the so-called radius of curvatures for the horizontal curve. So the super elevation has the following advantages. First of all, it allows the desired speed to be maintained on a curve on a straight portion. Because on a straight portion, usually you can have a very high speed or high desired speed. But when you are turning around, actually there will be centrifugal force applied on the vehicle. And then you can see that without using the frictions, well, actually, you can see that it is the V will be smaller because it's the RG and n times tangent x. It will always affect the maximum speed of the vehicle without if tangent x is equal to 0, right? So for this one, it is always important to provide the so-called super elevation. If not, actually, you can see that there will be centrifugal force applied on the vehicle. And then the smaller the R, actually the larger with the centrifugal force. And then if the friction is not enough, then actually you will have accident sliding of the vehicle easily. So in order to keep your vehicle at the same speed of the straight portion, you need to provide super elevations. And then it helps to keep the vehicle to the correct side. Well, as I mentioned, if you have a smaller radius of curvature, actually you require larger friction force. It either provide a larger friction coefficient or larger super elevation. If your E does not change or to be small, then actually you have to provide larger friction or friction coefficients. And then if you do not have enough friction, what will happen? If you want to keep the same speed, if you do not have enough mu, then what will happen? Your vehicle will slide away, right? Until the R is good enough to provide the frictions. Because when the R is larger, then the friction coefficient can be smaller. That means your vehicle will slide from one length to another length, so that the R will increase, and then your vehicle will become stable. Do you know what I mean? If you want to keep at the same length, Okay, actually, to provide higher friction coefficients, if there's no super elevation, if your friction does not change, that means actually your vehicle will slide from one lane to another. So you cannot keep your vehicle in correct side. And then you will lessen the danger of skidding and bends, of course, because sliding can be avoided if you have enough or you have higher or larger super elevations. And for sure, you will help your tire or wheels have less wear and tear because you have actually less friction required. Okay, so for this chapter, I will end here. And then actually there's some follow-up tutorial question that we can take a look first. And then you can go back and then try for yourself. For the first one, what are the major assumptions and calculation of vertical curve according to AASHTO guideline? For this one, I think you can refer to the notes, and then you will know what is the major assumption. Because we have the height assumption for the driver eyes, and then the obstruction height. And then the highway is being designed to AASHTO guideline with 100 km/h design speed. At one section, an equal tangent vertical curve must be designed to connect curve of 1% and then 2%. This one is actually the questions that I asked in the lecture. Okay? But here there's another follow-up question. Also work out the location of the highest point of the parabolic curve. That means you can find the values from the setting out equation. The vertical offset point of intersection of two tangents is PR. Then you may go home and then try by yourself to find the highest point of the parabolic curve and then the vertical offset point of intersections. And then a highway section is being designed to AASHTO guidelines to 100 km/h design speed. And one section, an equal tangent vertical curve must be designed to connect a grade of -3% and plus 3.5%. That means you will go from negative curve to positive curve. Determine the length of curve required, assuming provision to be made for desirable something like this in SSE. If using the truck size level at about 1.8%, what is the implications? So for this one, you may try by yourself. For here, I didn't mention about the reaction time. You may assume that it is 2 seconds. And then for the friction coefficient, I also didn't mention about that. You may assume it to be like 0.5, okay? But remember, when I didn't give you some numbers, you may assume it by yourself, okay? And then the fourth one is the purpose of the superelevation of the road surface is to balance the centrifugal force generated by a moving vehicle on a horizontal curve. Try to use the free body diagram of the first principle derived equation of calculation of superelevation. Now maybe in the test or in the examination, I may ask you to derive an equation like that, and then you may do it from the first principle of mechanics. That means I've already done it for you in notes. You may also try by yourself to start from 0 and then try to derive it by yourself. And then finally, a highway curve horizontal section is being designed to British standard with 85 km per hour speed, what is the minimum radius of curvature that can be designed? The importance assumption is shown below. Coefficient of friction is 0.15. Design superelevation is 70%. 45% of the centrifugal force is balanced by the force floor and 55% balanced by friction. If the design speed has to be increased to 100 km per hour, what's your suggestions? Okay? Now, those are actually using what we have mentioned today. You may try first, and then we can go through it in the next lecture. Okay? Okay, is there any questions before we end the class today? Okay, if no, then I will see you guys next Monday. Please come back for your test, okay? I will provide you the necessary equations, so you do not need to prepare for that. And then if you have some assumptions, stay in your answer sheet next week. So you just bring yourself to the class, of course with calculator, okay? And then the quiz is around 2 hours, okay? Just come to 1011. Any questions? Okay, if no, then I will see you guys next week, okay? 好啦，下個禮拜一啦，記住啦。Okay, see you guys.